Longitudinal variations in flow. The largest volume of ice being handled by a glacier is at the annual snow line. This must be so, for the total amount of ice increases progressively to the snow line because of accumulation, and progressively decreases below it through wastage. In a glacier of uniform cross-section and uniform longitudinal slope, the surface velocity must also have its greatest value at the annual snow line. In such a glacier, the average velocity should increase from the head of the glacier to the snow line and decrease from there to the terminus. Few glaciers are of uniform cross-section and slope, but allowing for irregularities in both factors, the decrease in surface velocity down glacier from the snow line is shown by both the Saskatchewan and Blue glaciers. Actually, much larger and more abrupt changes in the velocity are caused by variations in channel characteristics, particularly slope. What happens when a glacier slows down over a gentle reach in its course? The ice farther up glacier doesn't know anything about this, except possibly for a local backwater effect, and it keeps moving along at its usual pace, pouring material into the gentler reach. The result is that ice tends to pile up at the gentle reach. The glacier becomes thicker until it can handle the discharge at the slower velocity. Rivers of water do the same thing. Slow-flowing parts are deep. This behavior in glaciers has been termed compressive flow by John Nye of Bristol, England, who has demonstrated on a mathematical and physical basis how and why it occurs. One should not be misled by the term compressive. Ice in glaciers is to all intent and purpose essentially an incompressible solid. Except for elimination of air bubbles, the ice remains unchanged in density. The only compression that occurs is a shortening of a unit of ice, which is balanced by its increase in thickness. Have a great day.